This problem has to do with some basic statistics and selling oranges. So in the particular problem presented here, the average number of oranges sold is 4,700 with a standard deviation of 500. And the problem asks a few questions about what is the probability of selling so many oranges and so on. You can read the text in there yourself. I'm assuming as a student having a problem like this, you have access to something called z-tables. And what these cumulative z-tables are about are allowing you to estimate the probability of certain things happening given that there's normally distributed events or events distributed according to the normal distribution which your problem states the orange sales are. So of course the way the Z table works here is as follows here. Now I just got this table off of Wikipedia, but usually they're in the back of statistics books. The way the Z table works is something like this, and again I'll just echo the figure in Wikipedia here. If you have a distribution that's normally distributed, that means it's going to follow this bell-shaped curve distribution like that. It'll be a bell shape, so that's sort of the way your orange sales work. And the way the distribution works here is you choose some value here, some value of Z, and the numbers that you read off the table here tell you the probability of getting an event that's less than some number Z. So these are always events here for Z less than some number here, where the number that you're asking the probability about is at this line right here, Z. So it essentially gives you the area under the bell-shaped curve for the number that you're asking about. Now it's important to remember it's always the area less than Z as our problem unfolds here. But in either case, we'll just use the Z table to do that, and it's just an example here. Remember how the Z tables are used here. The digits down this column right here are the first two digits of the number you're interested in, and the numbers across the top are the rest of the digits. So for instance, if I needed to look up the Z value of 0.71, I'd go down here to 0.7, and I'd go over here to 0.1 because 0.7 plus 0.01 is 0.71, and I would read the number 0.7611 off, and that corresponds to the area under the normal distribution for all Z values less than 0.71. So that's the way we'll proceed then. Okay. So part A of your problem says, what is the probability of selling greater than 5,500 oranges? Now the first thing you have to do before you can get into using the Z table is you have to convert all the values in your problem into the Z values, and it's done with a simple formula that looks like this. The Z value for 5,500 will always be something like 5,500 minus your mean of 4,700, all that divided by 500. So in this case here, I'll get a Z value of 1.6. In other words, I know the question you're asking is 5,500, about 5,500, but in order to use the Z tables, we have to convert it to a Z value. So the equivalent Z value of 5,500 in your case is 1.6. And you're asking for the probability of being above 1.6, Z value above 1.6. So the Z value being greater than 1.6 means I can go to the table, but again, you have to remember that the table references only Z values less than a certain number here. But lucky for us here, the total area under this normally distributed curve here, this bell-shaped curve, is equal to 1. So although the tables give me the probability of being less than a Z value, if I need a probability greater than a Z value, as I do in this case here, I can just take the value out of the chart, subtract it from 1, and that'll be my answer there. So what I'll do then is I'll go ahead and look at the table for the probability of having a Z value of less than 1.6. I'll go down to 1.6 right here in the chart, and I see 0.959452. So the probability of having a Z value of less than 1.6 again is 0.9452. So I have that number here, but that's not quite what I want. I want the probability of having a Z value of greater than 1.6, which would be my answer for selling oranges greater than 5,500. But since the area under the bell-shaped curve is just 1, as far as these Z tables go here, then the probability of having a Z value of greater than 1.6, which is what I want, is just 1 minus the 0.9452. Or the answer to this problem here would be 0.0548, or if I multiply by 100, about 5.4%. So the chance of selling greater than 5,500 oranges is about 5.4%. So that's generally the way these problems are going to go. Let's just proceed here. Try and save a little room here, so I'll do part B right here. Now part B asks for the probability of selling oranges that are greater than 4,500. So once again, I'll convert the 4,500 to a Z value. And if I plug the 4,500 into this same formula over here, I'll get a Z value of this of minus 0.4. Okay, so I get a negative number here for the Z value. How do you handle negative numbers? Well, it turns out that the bell-shaped curve, if I go back to this figure here, is totally symmetrical like this. So it's a completely symmetrical curve like that, and this is where z, the middle of it right here, is where z is equal to 0. So if I have a negative z value, something like this, like your negative 0.4, how am I supposed to handle finding the area under the bell-shaped curve for negative numbers like that? Well, because it's totally symmetrical, the area under the curve less than negative 0.4, is that what we need in this problem here, is exactly the same as the area for values greater than 0.4. So what I can do here is, in this case here, I need the probability of selling oranges for a z value here, which is greater than negative 0.4, but because of the symmetry of the bell-shaped curve, which I just told you here, this is exactly equal to the probability under the bell-shaped curve for having a z value of greater than 0.4, as we said. And this we can just look up now. So the probability of having a z value greater than 0.4, again, with some of the issues we discussed in the last one here, in that the z table only gives you probabilities for less than a given number, I would just find 1 minus the probability of having a z value of less than negative 0.4. So it's very similar to the last problem in that regard. And if I go back to the z table and look up 0.4, I'll see it's right here, 0.6554. So the answer will be 1 minus 0.6554, or my probability of selling more than 4,500 oranges, which is equivalent to asking what is the probability of having a z value of greater than 0.4. In this case here would just be 0.3446, or about 34%. So the probability of selling greater than 4,500 oranges is about 34%. Okay, so moving right along. Part C of your problem here asks for the probability of selling less than 4,900 oranges. I'll write it that way there. And just following some of the things we did, we can compute the z value of that. It'll be 4,900 minus 4,700. So my pen is sort of dying here. Over 500 once again. So I will get a z value for this problem here of 0.4. So I get 0.4s are popping up a lot in this problem here. So this is going to be a straightforward one here, because I'm just asking for the probability of the z value less than 0.4. That's exactly what the table gives me straight up here. So I just go down to 0.4 and see it's 0.6554, 6554, and that is going to be my answer, about 65%. So the probability of selling less than 4,900 oranges is about 65%. So we'll just wrap it up with the very last part of the problem then. This is part D here. Number 4 as you asked here. The probability of selling less than 4,300 oranges here. Same procedure again. We're going to calculate the z value here. It's going to be 4,300 minus 4,700 over 500 here. So the z value is going to be negative 0.8. So really what we want to know is what is the probability of a z value here of less than negative 0.8. So a couple things like we considered before. These are negative values here, and our z tables don't have negative values, but as we discussed earlier here, the area under the curve for negative values is the same as the area under the curve for positive values. And of course, you can translate that sentence into saying the z value for values less than a negative number are the same as the z values for numbers greater than a positive number, because of the symmetry of the bell-shaped curve there. So this is going to be the same as having the probability of a z value of greater than 0.8, something like that. And now we can just translate this to the table here. We can look up the probability on the z table for these positive numbers here. But again, one other translation is, remember the original premise here is that the z value tables here only give the probability for having a z value of less than a certain number. This is greater than right here, but we're not deterred by that because the area under the bell-shaped curve is 1. So we'll just say that the probability of having a z value of greater than 0.8 is the same as the probability of having a z value of 1 minus the z value of less than 0.8. And this is the one that we can get off the chart. So as you use the chart, you also have to work to get your probabilities that you need to look up into a format of the probability of z of less than some number here. So I'll just go ahead and look up the 0.8, which is 0.7881. 1 minus 0.7881. 1 like that, and if I compute that, I get 0.2119, or about 21%. So the chance of selling less than 4,300 oranges is about 21%. So that sort of completes this problem here, and just a bit of a rehash here. when you have some real numbers from a real problem like this, you always convert them to their z-values like this here, using this formula here, which I just highlighted a bit for you here. The z-value is always found by putting in the actual value you need, subtracting the average, in this case here is like x bar, sometimes books call it mu, and you divide all that by your standard deviation. This gives you the z-value right here. And going back and using the z-value charts, you have to remember that all these numbers here are always for probabilities of events to be less than z. So it's always, you can just imagine this line here, which is the value, the z-value you're interested in, but the numbers here are always for a value less than z like that. But luckily, the total area under the curve here, as I said here, is equal to 1. So you can always use, if you need the probability of a z-value to be greater than a certain number, you can always use 1 minus the probability of a z-value less than a certain number here. So you sort of have to get used to using the tables like that, and there's some other considerations for negative numbers. I found wonderful tutorials on all of this stuff on Wikipedia and other places on the web, so you can definitely refresh yourself that way. But I think these should cover the answers that you need. Please let us know if you have any more questions.